This part of the training covers event type topics. This is also a programming interface section. Please skip if you don't need programming information. The first part asks, what is an event? And what are event representations? There are 6 different event representations. The application type object, wherein the application code contains a class that represents the event. The map instance implements the java.util.map interface. The object array is an array of objects. The JSON string is a text formatted as JSON. The Avro record is an Apache Avro library record. The XML document object model for processing XML documents. The next topic compares event representations in terms of performance. The discussion then reviews event type and event bean. The next topic is event representation for output events. Finally, we look at variant streams, which are streams that can hold any type of event. An event is an immutable record of a past occurrence of an action or state change. Event properties capture the useful information for an event. Or, event means something that happens, according to Webster.com. An event is an immutable object. Immutable means there are no setters and no changes are allowed. Event property values and their nested data must also be immutable. There must be one object instance per event. Processing the same event object reference multiple times is not allowed. Event property objects can be shared between object instances. What is an event representation? An event representation is the underlying event object and its type. Every event object is one of these. A. An application class object, typically a POJO bean, and POJO stands for plain old Java object. For instance, com.company.mypackage.withdrawal. B. An implementation of the java.util.map interface, or dictionary in the C# programming language. C. An object array, that is an array of java.lang.object. D. A JSON string or object model, to be explained later. E. An Apache Avro org.apache.avro.generic.generic-data.record. F. An XML document object model org.dom.node instance. G. A pair of object and map. A pair of an underlying event object and additional properties. A pair is only used for output events and depending on the select clause. Incoming events must be transformed into one of the above. This slide explains the reason why there is a variety of event representations. Esper has multiple event representations since there are trade-offs. There is a performance trade-off in accessing event property values. For instance, bytecode that accesses a getter method is faster than bytecode that performs a map lookup. There is a trade-off in memory footprint. For instance, a map requires more memory than a POJO, plain old Java object, and object array. There is an ease-of-use trade-off when transforming incoming and outgoing data. There is an ease of development trade-off in whether a type is self-descriptive or not. For instance, a map has name-value pairs and object array is harder to read by human eyes. There is a trade-off in serialization performance when using high availability. There are high-performance serialization options for POJOs and object array but not for maps. This slide answers the question how event representations affect the EPL. The short answer is that event representations don't affect the EPL. The EPL is the same regardless of event representation. For instance, consider the following EPL. Select my property 1, my property 2 from my event. My event can be any of application class object, map, object array, JSON or other, but the EPL is the same. This allows EPL to generally stay the same when switching to a different event representation. Any event type can use any event representation. Thus you can mix and match, choosing the event representation that fits best. The convention for naming event types and event properties is camel case for event type names, with the first letter as uppercase. Camel case for event property names, with the first letter as lowercase. Let's review the details of adding and removing event types. You can add an event by either A. Adding it to the configuration as a pre-configured event type. B. Using create schema to define the event type in EPL. You can remove an event type by A. Not adding it to configuration. B. Undeploying the deployment that contained the create schema. When using create schema, event types of events that an application can send into a runtime for processing must have the @bus event type and the @public annotations. Without the @bus event type annotation, the runtime does not process the event type when calling the send event method. This makes sure there is no accidental sending of event objects that shouldn't be events. This slide and the following slides discuss the different event representations. The following slides all define a withdrawal event type. The withdrawal event type has two event properties, account ID and the amount. This slide discusses application classes, objects and plain old Java objects as events. Your application can pre-configure the event type in configuration or use create schema to define it in EPL. To pre-configure the event type, use the addEventType method and pass the class of the event. For example, configs.getCommon.addEventType (withdrawal.class). The addEventType method has multiple footprints and can add a class by class name and can take more parameters. The alternative is defining the event type in EPL. This is done by create schema and the class name. For example, add public @bus event type create schema withdrawal as com.mycompany.package.withdrawal. It is not necessary to provide the package name of the class, provided that the configuration object lists the packages and imports. So it is also sufficient to say add public @bus event type create schema withdrawal as withdrawal. The code that illustrates how to process events is runtime.getEventService.sendEvent (withdrawal, withdrawal). A Pojo class has getter methods for properties according to the Java Bean standard. Pojo stands for plain old Java object and is a standard. For select account ID from withdrawal, the compiler generates bytecode that calls the getAccountID method. Typically the event type name is the simple class name, but you can assign any name and can use the same class for multiple event types. The map event representation relies on the java.util.map interface. Pre-configure the event type by calling the addEventType method and passing a map of string keys and object values that define the event property names and types. The addEventType method has many footprints and we just review one alternative here. For example, map props equals new linked hashmap. props.put account ID, string.class. props.put amount, big decimal class. configs.getCommon.addEventType (withdrawal, props). The next example defines the event type in EPL. Add public @bus event type create map schema withdrawal as (account ID string, amount, big decimal. This code processes map events. Runtime.getEventService.send event map (withdrawal, withdrawal). For select account ID from withdrawal, the compiler generates bytecode that calls the map's get method passing the string account ID. The map event representation is the default type for output rows. The object array event representation supports sending an array of objects as an event. An application can pre-configure the event type by calling the addEventType method and passing an array of property names and an array of property types. For example, string array names equals new string array curly double quotes account ID comma double quotes amount. Object array types equals new object array curly string dot class comma big decimal dot class. Configs.get comma dot add event type double quote withdrawal comma names comma types. To illustrate, see the EPL here that defines the event type. At public at bus event type create object array schema withdrawal as account ID string comma amount big decimal. This code processes object array events. Runtime.getEventService.send event object array withdrawal comma double quote withdrawal. For select account ID from withdrawal, the compiler generates bytecode that gets the account ID event property value from array at index 0. The JSON event representation supports sending a JSON formatted string as an event. An application can only define this event type in EPL. It is not possible to pre-configure the JSON event type since the compiler generates a custom JSON parser and custom JSON value object. For example, at public at bus event type create JSON schema withdrawal as account ID string comma amount big decimal. The code that processes JSON events is shown here. Runtime.getEventService.send eventJSON withdrawal comma double quote withdrawal. The compiler generates a value class for the schema, and a parser that can parse a JSON string. Alternatively, the application can provide a predefined value class. For select account ID from withdrawal, the compiler generates bytecode that gets an event property by calling the getter method of the generated value class. Upon receiving a JSON string, the runtime invokes the generated JSON parser and obtains an underlying object of the generated value class. The Apache Avro event representation supports sending an Avro record as an event. An application can pre-configure the event type by calling the addEventType Avro method and passing specific configuration. For example, configuration common event type Avro equals new configuration common event type Avro. Avro.set Avro schema text Avro schema. Configs.get add event type Avro double quote withdrawal comma Avro. This is the EPL that defines the event type. At public at bus event type create Avro schema withdrawal as account ID string comma amount big decimal. The following code process an Avro event. Runtime.getEventService.send event over withdrawal comma double quote withdrawal. For select account ID from withdrawal, the compiler generates bytecode that gets the field value at the Avro field index that the schema defines. The XML document object model event representation supports a XML document object as an event. An application can pre-configure the event type by calling the addEventType method and passing an XML-specific configuration that we don't discuss further here. There are various options depending on the use of XML schema and XPath. The following code processes an XML document object model event. Runtime.getEventService.send event XML dom withdrawal comma double quote withdrawal. For select account ID from withdrawal, the compiler generates bytecode that navigates the DOM according to the XML schema, if specified. This page analyzes performance of reading an event property value for the different event representations. On the left side of the table is the event representation. On the right side of the table is information about the bytecode produced by the compiler for the event representation. The table provides performance remarks in respect to reading an event property value, such as select account ID from withdrawal. This EPL selects the account ID field from withdrawal events. For application classes including for plain old Java objects, the compiler produces bytecode that calls the getter methods. For map interface implementations, the compiler produces bytecode that calls the maps_get method passing the event property name. For object arrays, the compiler produces bytecode that accesses the array by index. For JSON, the compiler produces bytecode that calls the getter method, since the compiler produces a custom value class that provides a getter method. For Avro, the compiler produces bytecode that calls record.get property, index. For XML document object model, the compiler produces bytecode that navigates DOM. POJO, JSON and object array offer the best performance in respect to access to event property values. More comparison can be found in the documentation under comparing event representations. The event type interface provides type information. Here we discuss the various ways the code can obtain the event type. The EP statement returns the event type. For example, EP compiled equals compile parenthesis quotes select account ID comma amount from withdrawal. EP deployment equals runtime.get deployment service.deploy parenthesis compiled. EP statement equals deployment.get statements at index 0. Event type equals statement.get event type. The runtime's event type service returns event types. For instance, event type equals runtime.get event type service.get event type parenthesis quotes withdrawal. This method returns only types that are bus event types or that are preconfigured. For event types that were defined as part of a deployment and that are not bus event types, pass the deployment ID. The sample is event type equals runtime.get event type service.get event type parenthesis deployment ID comma quotes withdrawal. Event bean instances also return their event type. This sample code is update listener code. Event type equals new data at index 0.get event type. The event type interface returns the property type of event properties. The get property type method takes the event property name and returns the property type. For instance, class property type equals event type.get property type parenthesis quotes account ID. The event property getter interface returns the property value of a named property. An example is event property getter equals event type.get getter parenthesis quotes account ID. Object value equals getter.get event bean. The get underlying type method returns the class of the event representation. So it returns the POJO class like withdrawal.class, or map.class, or object array.class, or JSON event object.class and so on. For example, class underlying type equals event type.get underlying type. The getName method returns the event type name. The getPropertyDescriptors method returns all property names and types. The getSuperTypes method returns supertypes. The event bean interface composes the event type and the underlying event object into one. And the underlying event object is one of these application objects such as the withdrawal object, or map instance, or object array, or JSON, or Avro record, or XML DOM node. The getEventType method returns the event type. The getUnderlying method returns the underlying event. The get method takes a property name and returns the property value. For instance, object value equals event bean.get parenthesis quotes account ID. This slide and the next 3 slides discuss the event type of output events. Output events are event bean instances. The event type of event bean output events depends on the select clause, and whether there is an insert into clause and whether the insert into name already exists. Select star passes through the same event underlying object. Select star is therefore zero copy, no property reading. However, joins are discussed elsewhere. The example query is select star from withdrawal. The input event and the output event are the same underlying event object, same object reference, i.e. the same withdrawal object as send in regardless of whether processing an application object, map, object array, JSON etc. When selecting only expressions, and not selecting star, the compiler determines expression names and expression result types. Consider the query. Select account ID, amount from withdrawal. Each output event's underlying object is a map that has 2 entries, account ID of type string and amount of type big decimal. See earlier create schema examples. There is also a compiler configuration that changes the default underlying type to object array. The compiler validates all expressions and determines the name and type of each event property. The as keyword can be used to provide an event property name. Selecting expressions and star produces a pair of the original event with a map for additional properties. The EPL for this example is select amount -400 as threshold, star from withdrawal. Each output event's underlying object is a pair of withdrawal and a map with 1 entry, threshold of type big decimal. The runtime uses a pair so that the underlying event object can be passed on and additional event properties can be added, thereby the runtime does not copy event properties. When using insert into, and the event type is undefined, the compiler defines a new event type implicitly. For instance, and assuming the withdrawal filtered event type is not defined elsewhere. Insert into withdrawal filtered, select star from withdrawal parenthesis amount greater 400. Select count star as count greater 400 from withdrawal filtered. The compiler implicitly defines the event type withdrawal filtered and it has the same event representation as withdrawal since there is a select star. When using insert into, and when the event type is already defined, the runtime produces events of that event type. Like this example EPL here. Create schema withdrawal as parenthesis account ID string, amount big decimal. Insert into withdrawal, select quotes 001 as account ID, 10 as amount from some other event. The compiler validates, for each event property, that the select clause expression result types and the inserted into event property types match. Widening is necessary. The runtime never copies events. Except, updating events may shallow copy an event underlying object, to be discussed later. The runtime never copies event property names and values. A variant, or discriminated union type, is an event type that can hold a value of any of a finite set of event types. Variant event types provide type variation. A variant event type hold one or more predefined event types, or it can hold any event type, currently defined or to be defined. Variant event types have different event property policies. Properties shared between types are strongly typed. Properties can be untyped and their type is java.lang.object. Variant event types can be pre-configured in configuration or can be defined by create schema. Define using create variant schema and provide a list of event types names or a star. The following two examples illustrate variant event types. The first example defines a variant event type that accepts only login event and logout event types. Create variant schema security event as login event, logout event. Insert into security event select star from login event. Insert into security event select star from logout event. Select count star from security event. The second example defines a variant event type that accepts any event type. Create variant schema any event as star. Insert into any event select star from login event. Insert into any event select star from page browse event. Select user ID ? Page time ? from any event. We are using ? to instruct the compiler that the EPL can be compiled without checking for valid property names at time of compilation. Output events have the event property value or a null value for the respective property. The compiler validates the insert into to ensure the event type is allowed according to the create variant schema.